Now we will solve our second internal paper, which was an MCQ paper. So, so let us do our first question. Which of the following interpolation technique is used to find the value of a function at a point lying outside the known data point? So see, its answer should be D, Lagrange's theorem, because if we see to the Lagrange's theorems, its formula is summation I from I equals to 1 to n bracket pi j equals to 1 to n x minus xj upon xi minus xj multiplied by I. So let us understand this formula more clearly by solving one question. See, we have x and y. We have given some data points like at x equals to 5, value of fx is 12. So in such a way, data is given, and we have to find the value of y at value x equals to 10, right? So what we will do is use this formula, that is x minus x x of j, that is 1. So it will be 1, 2, 3 and 0, right? So x minus x1, x minus x2, x minus x3 upon xi minus xj. Here I is what? 0. So x0 minus x1, x0 x0 minus x1, x0 minus x2 into x of 5, right? Similarly, we have done with this, this and this, and after solving this whole equation, we will get what? Value of 14.666, right? But if we want to find the value, let's say x equals to 12, we can also solve at value of x equals to 12 using this formula only. Just in place of x, put the value of 12, and we will find the value of a function outside the data point. So its answer will be D, Lagrange's theorem. Let us proceed to our second question, which is which of the following is not a disadvantage of Newton forward interpolation? So if we look carefully, we have to find which is not a disadvantage. Means it should be advantage, right? So first option A is it cannot be used for large value of n. So it's a disadvantage. So it cannot be true. It cannot be a correct answer. Sorry. It requires equally spaced data points. This point is true, but it's one of a disadvantage of Newton forward interpolation, right? It is sensitive to errors in a data points. Yep, that is also true because in approximing the terms, it could lead to a wrong answer. So it is also a disadvantage. It is computationally intensive. Yep, it is true. To understand the meaning of computationally intensive, it means computationally intensive is a term that applies to any computing application that requires multiple computational resources such as grinding computer, right? It means it requires multiple data so that we could find the correct answer more precisely. So it is an advantage of Newton forward interpolation. So D, right? D is a correct answer. Now let us see the third question of our test, that is which of the following interpolation technique is used to find value of a function at a point lying before the data point. So it should be, we have to find lying before the known data point. It should be Newton backward interpolation. In Newton forward, we find the point lying after the known data point, and Newton backward interpolation, we find the data which is before the known data point, right? So what? So let us proceed to our fourth question. Which of the following interpolation techniques uses a polynomial of degree n minus 1 to interpolate n data points? So it should be D, Lagrange's interpolation. Why? Let us see the Lagrange's interpolation formula. So this is Newton Lagrange's interpolation formula. So in this example, you can see we have four data points, right? 1, 2, 3, 4. And if we see this equation here, right here, so we can clearly see that if we solve this equation, it will be of which order? 3 order, right? Because all these terms are in multiplication and x into x into x will be 3. So highest degree would be 3, right? And we have 4 data points. So if we have n data points, Lagrange's interpolation gives n minus 1 polynomial to solve the equation. So it should be D, Lagrange's interpolation. Let us proceed to question number 5. Question number 5 says, which of the following is not a disadvantage of Newton backward interpolation? Option A, it requires equally spaced data points. It is a disadvantage. It is sensitive to error in the data points. It is also in disadvantages, and we have to find which is not a disadvantage, right? It cannot be used for large values of n. It is also in one disadvantage of Newton backward interpolation. So answer should be D. It is computationally intensive. Let us proceed to question number 8. Which of the following is a correct formula for first dividend difference in Newton dividend difference interpolation? Option A is f of xi equals to f of xi. No, this cannot be. F of xi equals to f of xi plus 1 minus f of xi. No. So let us see first the what is the formula. The formula is f of x0 comma x1, that is f of x minus f of x0 upon x minus x0, right? So it should be option number D, right? Xi minus x of I minus 1 x of I minus x of I minus 1. Yep, this is true. It cannot be C because here it is x of I plus 1. So it has to find a one digit mode like x of 5 minus x of 4, and it could cause an error. So answer will be option B. So let us proceed to the question number 9, which is what is a basic difference between the Newton forward and backward interpolation methods? So option A is Newton forward interpolation uses forward differences, where backward interpolation uses backward while Newton forward. So for this, we should see the formula first. So here are the formulas for Newton forward and Newton backward interpolation. In Newton forward interpolation, we use what? Forward difference operator, right? Here you can see it. And in Newton backward, we use nebula, which is Newton backward interpolation, Newton backward operator, right? So what will be the correct option? Forward uses forward difference, right? And backward uses backward difference, right? So answer will be A. Let us proceed to question number 10. In Newton dividend difference formula, what is the purpose of using higher order differences? To increase the accuracy of the interpolation? Yes, that can be true. To decrease the accuracy of interpolation? No. To make interpolation faster? Nah. D, none of these, none of the above. No, none of the above cannot be because it is looking true. Let us see through a question. See, we have a question like we have given x values 5, 6, 9, 11, and fx values 12, 13, 14, 16. So we have finded the dividend forward using forward difference operator, that is 1, 1 by 3, 1, and we have applied this formula in this question, and we have find the values. So higher degree, higher order differences. So what does higher order differences are? Higher order differences are these terms, right? 1, 1 by 3 and 1. So in calculation, there is 1, 1 by 3. These calculations are used to give increase the accuracy of our question, right? So answer should be A, to increase the accuracy of the interpolation. let us proceed to question number 19. What is the main difference between the Newton-Cotes formula and Gaussian-Quadratis formula for a numerical integration? Newton-Cotes formula uses equidistant points, whereas Gaussian-Quadratis formula use non-equidistant points. So it should be remembered that Newton-Cotes formula uses equidistant points and quadratic formula use unequal or non-equidistant points, right? So let's see other options as well. Newton-Cotes formula uses non-equidistant points, whereas Gaussian quadratic formula uses equidistant points. No, this is false. Both Newton-Cotes and Gaussian quadratic formula uses the same type of points for integration. No, this is also wrong. So it will be A. Newton-Cotes formula uses equidistant points. So it will be A. And Gaussian quadratic formula uses non-equidistant points. Now see 20th question of our second internal paper. Which of the following is an example of Newton-Cotes formula for numerical integration? Simpson one-third rule, Simpson 3/8 rule, trapezoidal rule, or both A and C. So from Newton-Cotes formula, we can derive both Simpson one-third rule and Simpson 3/8 rule. So answer will be D, both A and C. So if we want to go in a detail, so this is a Newton-Cotes formula, that is I equals to nh summation I equals to 0 to I equals to n y into ci raised to the power n. So here what does this ci raised to the power n means? This ci raised to the power n, it's a Cotes number which we use, and here li is u minus u0, u minus 1, u minus 2, right? So if we want to find Simpson one-third rule, we put value of n equals to 2 here. So if we put value of n equals to 2 here, it will become 2h summation I equals to 0 to 2 yi ci raised to the power 2, right? So now we will apply this formula and find value of ci. So it will be equals to I equals to 2h y0 c0 square plus y1 c1 raised to the power 2 plus y2 c2 raised to the power 2. We have just expanded this term, right? 0 0 1 1 2 2, right? Now we will go for value of L, Lagrange's number. So for value of Lagrange's number, c0 square will be what? 1 by n, integration of 0 to 1 by n. So here n will be what? 2. So 1 by 2 integration 0 to 2 L0u, right? So here these values will come using formula. Here these values will become, and here this value will come. If we solve this, we will get 1 by 6, 4 by 6, and 1 by 6, and putting these values in the formula here, right, again. So we will get Simpson one-third rule. Similarly, if we put n equals to 3 here, we will get the Simpson 3/8 rule. Okay, that is here Simpson 3/8 rule. So the correct answer will be D. That is, we can use both both A and C in Newton-Cotes formula for integration. Example of Simpson one-third rule and Simpson 3/8 rule is the example of Newton-Cotes formula. So let us proceed to question number 15. Question number 15 says, what is the order of the polynomial used in Newton forward interpolation? So let us see the Newton forward interpolations formula, and it is f of a plus h equals to f of a plus u upon factorial 1 del of fa plus u upon u minus 1 upon factorial 2 del square of fa. So if we find out the nth term of this expression, it will be u into u minus 1 into u minus 2 up to u minus n minus 1, right? Because let's see here, it is what our second term starting from 0 0 first second, so it will be into u minus 1, so here it will be n minus 1 upon factorial n minus 1, right? It is what our first second third term minus 3 minus 1, it is 2 into del n minus 1 of fa, right? So if someone asks you about order, what will be it? It will be this n minus 1. So answer for 15th question will be n minus 1. To question number 16. Which of the following interpolation method uses the concept of interpolation error? Newton forward, Newton backward, Lagrange's, and none of the above. So it should be C, Lagrange's interpolation. Because what do you mean by interpolation error? First we will understand that interpolation error is the difference. Interpolation error is a difference between interpolated value, the value which we have found through interpolation, minus the actual value that we have put directly in the formula, right? And what this interpolation error is used for? Interpolation error is used for finding the accuracy of that interpolation method. If the value is small, it is more accurate, and if the value is big, it is less accurate, right? So what is the concept? Lagrange's interpolation uses the concept of interpolation error to estimate the accuracy of the interpolation. The interpolation error is the difference between the true function and the interpolated function that I have tell you. By computing the interpolation error and the error bounds, we can assess the quality of interpolation and make the informed decision about the number and spacing of interpolation points needed to achieve a desired level of accuracy, right? So it should be C. Proceed to question number 17. Which of the following interpolation method can be used to interpolate a function with complex values? Newton forward, Newton backward, divided differences, Lagrange's. So Newton forward and Newton backward can't be the answer because these two uses forward difference and backward difference operator, right? And calculation of complex values is not possible in forward and backward difference operators, right? In divided difference interpolation, we use the concept of divided differences, right? So its computation is so much higher, so we can't use complex values in even in divided differences operators. So answer will be Lagrange's interpolation. So answer will be D, Lagrange's interpolation. Let us proceed to question number 18. What is the drawbacks of using a higher order differences in Newton divided difference interpolation? Higher computational complexity, decreased accuracy. This is not an drawback. What is degree of higher degree of polynomial approximation? Not so. None of the above. So answer will be A. Higher computational complexity is a drawback of a higher order differences because its values will be complex, and to solve that it will take more time. So it is one of the drawback of Newton divided difference interpolation.